Differentiation of basic trigonometry. If you have a function capital F equals f of x, that means that function is a function of x. If y equals a sine of f, then the derivative of y is going to be the derivative of sine of f, which is cos of f, times the derivative of f, which is df dx. Likewise, if you have y equals a cos f, and the derivative of y dx will be minus a sine of f, which is the derivative of cos f, times the derivative of f, which is df dx. If you have a function y equals a tan of f, the y dx will be a sec squared f times the derivative of f with respect to x. If you have y equals a cotangent f cot f, the derivative will be minus cosec squared f, that's the derivative of cot f, times the differential of f with respect to x. This process is called chain rule, where you differentiate the cot f, which is that one, and then you times it by the differential of f with respect to x in this case. So for chain rule, where y equals to a capital F to power of n, the y, the x, will be a n f to power of n minus 1 times the f over the x. This one here is the y over the f times the f over the x, and that gives you the y over the x. This is what we called chain rule. The f, we cancel the f, you're going to get the y dx back, which is the y dx. Let's start with an example. Y equals sine of x. We're going to apply chain rule here. Remember, I'm going to rewrite this one as y equals a sine f, where a equals 1 and f equals x. The y, the x, will be a cos f times the f over the x. A is 1, so I can write the y over the x equals 1 times cos f, but f is x, so cos x, times, what is the f dx? Well, so the f, the x, is going to be, I'm going to differentiate that, so it's going to be 1x, 1 times x to power 1 minus 1, because n is 1, 1 times x to power 0, but we know x to power 0 equals 1. So that will be 1 times 1, and that equals 1. So now we could have the y, the x, equals 1 cos x plus 1, which is equal to cos of x. Let's try another example. Y equals to tan 5x. We can write that as y equals to a tan f. And we know a equals 1 and f equals 5x. So we could say the y, the x, is a sec squared f times, which is dot, the f, the x. But we know what the f, the x is. The f, the x, is basically 5x to power 1 over the x, and that will be 5 times 1, x to the power 1 minus 1, and that is 5 times 1, which is 5. So the f dx is 5. So we can then bring it down here and write the y dx will be a is 1 times sec squared 5x, because f is 5x, times 5 sec squared 5x for the y dx. And also, this is the answer we're looking for. Y equals sine x. So basically what just happened is function of function. We do sine of x is cos x times the differential of x, which is 1. So that's differential of x, which is 1. So if I can just put that there, so that's 1. Right. And the next one, what we did upon is y equals tan 5x. So with times, we do 1. So we do differential of 5x. Tan 5x is sec squared 5x. And we then times it by differential of 5x, which is 5. So the y dx is 5 sec squared 5x. Here are some exercises for you to have a go. The question 8 is the most challenging one, so you can have a go last, question 8. And the answers are provided next. So pause, do the question first, and then check the answers. So for question 1, y equals sine 4x plus 3, where a is 1, f is 4x plus 3, which basically means 4x to the power 1 plus 3x to the power 0, because x to the power 0 is 1. That has its variable too, it's x to the power 0. So I did the f dx first by differentiating that one, and that is 4 times 1, so you bring the 1 down, times then x to the power 1 minus 1, that's n minus 1. Same thing with this one, 3 times, you bring the 0 down, 0 times x to the power of n minus 1, but n is 0. N is 0 here, n is 1. So that is 0, obviously, and the 4 times x to the power 0, x to the power 0 is 1, so you get 4. So the f dx is 4. Now you can write the y dx. And the y dx for sine, the y df for sine is cos. So that's a is 1 times cos f is 4x plus 3 times the f dx, which is 4. So that gives you your answer. Question 2 is y equals to tan 5x. We've done that question before, so that's a straightforward question there. Question 3 is y equals sine squared 3x. Well, I can rewrite that one actually as sine 3x all squared. So that's what I meant. It means you squared everything. And I've called these f equals sine 3x f, and what I then do is y equals f squared. So I'm going to find the y, the x would then be the y, the f, which is 2, bring the 2 down, then f 2 minus 1, that's what that is. So that's the y, the f, so the f, the x. And so that's 2 f to the power 1 times the f dx. I know what the f dx is. It's cos, well, you differentiate that one, which is cos 3x, and times it by derivative of 3x, which is 3. And So that's the f dx. And so now I need to complete the dy dx, which is 2. That's the 2 there, f, we know what f is, sine 3x times the f dx. The f dx is 3 cos 3x. And 2 times 3 is 6, sine 3x cos 3x. Question 4. We got y equals 4 cos 7x plus 2. Well, again, I've written that as y equals a cos f, and a is 4 in this case, and f is 7x plus 2. I can rewrite that as f equals 7x to the power 1 plus 2x to the power 0. So there's x to the power 0 next to a constant. And the f over the x will be 7 the x to the power 1 over the x plus 2 the x to the power 0 over the x. And to not differentiate that is 7 times, you bring the 1 down, so that's 1 times, because n is 1, so you bring it 1 down, and then x to the power 1 minus 1, so n minus 1, plus, this case, 2 times, you bring the 0 down, 0, times x to the power 0 minus 1. So 2 times 0 is 0, so that's 0. 7 times 1 is 7 times x to the power 0. X to the power 0 is 1, so that's 7. So the f dx is 7. So now I need to bring it here and put it there. Now if I differentiate cos f, I get minus sine f. But I know what f is. F is that. So I'm just going to replace it there. So I'm going to get minus 4 because a is 4. And the minus is coming because I'm differentiating cos. That will give us minus sine f. And times the f dx. The f dx is 7. So I got 7. So that's 7 times that. 7 times 4 is 28. That's minus 28 sine, open bracket, 7x plus 2, close bracket. So that's the derivative of that function. Question 5. Y equals 1 over 3 plus cos 2x. So in this case, I have to change that into that. So now I've got my n. So this is n, and that's a function to the power of n. I need something to the power of n to differentiate or integrate. So I've written it like that, where f is going to be 3 plus cos 2x, and the n is going to be minus 1. So n is minus 1, a is 1, because there's 1 here. And so now I can apply this differentiation here. The y dx will be, I need to apply this. A is 1, n is minus 1, times f, but f is 3 plus cos 2x. That's 3 plus cos 2x to power minus 1 minus 1, so minus 1 minus 1, times the f dx. But the f dx I need to find. So I'm differentiating that. So if the f dx would be 3, take the constant out, x to the power 0, well, that will be 0 anyway. So bring the 0 down, that will be 0, so that's 0. Times differential of cos is minus sine. So cos 2x minus sine 2x times the derivative of what's in there of 2x, which is 2. And therefore I get 0 minus 2 sine 2x. And so the f dx is minus 2 sine 2x. And I need to put that here, which is here. So that's why I get that first, because minus times minus is plus. That's why I get a 2. And then sine 2x, which is that one, times this one here, which is 3 plus cos 2x to power minus 2. That's minus 2. Right. This is on top. This is just to power 1. So that's okay. That's that one. But I need to rearrange that one now. So that, because it's to power minus 2, that be 1 over, So that's why it's in the denominator, because it's to the power minus 2. So now 1 over f squared is equal to f to the power minus 2. So we've got the here is f to the power minus 2, and I just put it back in that format. So that's what that is. So question 6, y equals to sine 1 over x. Well, so I've just written it like that, and a is 1 because there's 1 here. F is equal to x to the power minus 1, which is 1 over x. That's the 1 here. That's that one, the 1 here. So I could actually put it here to make sense of that. That's that 1. All right. So, and so that in that case, I need to put it in that format because it's easy to work with in that format. So now I can now do the f dx, which is you bring the 1 down, so that's minus 1 times x to power minus 1. This is n, so that's minus 1. So minus 1 is minus x to power minus 2. Again, I can write this 1. This is 1 over x squared. So that's minus 1 over x squared. So the f over the x is minus 1 over x squared. Now, doing this sign, so y equals a sine f, and the y dx will be a cos of f times the f dx. I've got my df dx, which is that one, and I know that's cos, and that's f. F is 1 over x, so I can write the y dx is 1 times cos 1 over x times minus 1 over x squared. And in that case, I can then write the y dx equals to, now that's minus, so that's minus cos 1 over x over x squared in the denominator, and bring it out in the denominator, so you're going to get minus 1 over x squared, still in the denominator, cos 1 over x. Question 7, y equals to sine x plus cos x to power 5. So all I've done is y equals f to power 5. F is sine x plus cos x. The f dx to be equal to the sine x over dx plus the cos x over dx. Well, the f dx would be, if I differentiate sine x, I get cos x. If I differentiate cos x, I get minus sine x. So that's the f dx. And since I've written it like that, so I've got y equals a f to the power of n is 5, and a is 1. Knowing that f is a function of x, so you can see the x here. So the y dx is a, the f to the power of n, divided by the x, which is a n f to the power n minus 1 times the f dx. So that's the formula we're using for that. And so we can write it here. The y dx is 1, a is 1, n is 5, f is sine x plus cos x, open and close bracket, to power 5 minus 1, which is 4, times the f dx, which is that one, cos x minus sine x. So now I can write the y dx equals 5 cos x minus sine x times sine x plus cos x to power 4. And that's the answer. For question 8, it's a bit more challenging. So you have to convert the y equals root sine root of x. You change the roots into their exponent. So there will be y equals sine x to the power of a half and all to the power of a half. So you have to change that to their indices. And therefore you get y equals a f to the power of n. That's what we've got here. So you can see what f is. F is that one, and a is 1. So n is a half. That's that, a half. A equals 1, and f is sine x to the power of a half. The f dx is cos x to the power of a half. Because if you differentiate that, you're going to get cos times the derivative of that, which is this one. So that will be a half x, a half minus 1. And that gives you a half times x to the power minus a half times this one here, cos x to the power of a half. But this is cos root x, because x to the power of a half is root x. So that's why you've got cos root x. Divided by 2, this is that 2, and x to the power minus a half is 1 over x to the power of a half, which is 2 root of x. Now the y dx is going to be a n f to the power n minus 1 times the f dx. The f dx is that one. So now we need to find the y dx, which is a is 1 times n is a half times f. We know what f is because I've made f sine x to the power a half. So that's sine x to the power half, all to the power a half minus 1 times the f dx. And that is a half. That bit here, that's root x, so that's root x, all to the power minus a half times the f dx, which is that one. So now the y dx is going to be, well, 2 times 2 is 4 at the bottom denominator, and you got root x times root sine root x. So that will give you, if you have root a times root a, you're going to get root ab. So that's why you're going to get x sine root x, because you're times in there to get an all root. And that's how we got the answer.